All right. So I think if I didn't lost track of the count, I think last thing we did was discuss security architecture. So what would be my suggestion for today is to discuss the secure build security practice. Unless somebody would really like to discuss another practice, we're of course open to requests. But if we just take it chronologically, the next logical thing to discuss would be the secure build. If there's strong objections, please let us know. Otherwise, we'll dive into this one. And I see no objections there. So we have in the secure builds, which is part of implementation. And as a reminder, implementation is a new business function in the OWASP SAMM 2.0 model. It was not there in the previous versions of the model. We were very much in favor of adding build, deploy, and defect management. So we added another business function for that. And in those functions, so the first security practice, secure build, it consists of two streams. One stream is build process, the other stream is software dependencies. As a general reminder, these streams are just there to help us structure a bit the model. There is no priority or dependencies whatsoever between these streams, or one stream being more important than another stream. So they're all equally important, these streams. It's just a way of structure the model a bit more. So each stream has 3 maturity levels. Let's first dive into the build process stream. So we're gonna, at this first level, we're gonna try to make an a definition of our build process so that it becomes consistent and repeatable. Let's dive into details a bit more. At the second level, we're gonna automate it further and make sure that you include security testing or tooling in there. And at the third level, we're going to actually make the security testing mandatory and make the build stop when something is not according to what you expect in the build process. So at the first level, so the idea there is to define the build process to make it repeatable and consistent. Let's see what we can be discussing there. So the idea is really to make sure that whenever you want to build the application, that when process A builds it and when process B builds it, or when you build it today and in 3 or 6 months time, the results will be the same. That is really the idea, to have a build process that is really consistent and repeatable. That means that you will have to have your build process in some way defined. It can be through a CI/CD tool. It can also be in a description somewhere where you clearly state what the different steps are that you need to take. It doesn't have to be all automated, but it has to be defined. It has to be formally defined. So as a very borderline example, if you want to write your build process in Notepad, but really very clearly define what the steps and the commands are so that somebody can just literally execute them, that would be a very, a borderline case of this, but it's a very minimalistic case of what we mean. Of course, the idea would be to more, have some tool support around it to make your life easier. So it's about about making the different steps clear, also about making different tools clear. So you might want to have the compilers in there, you might want to have obfuscators in there, you might want to have connections with vaults there to get credentials or so. I don't know. The different things that you want to do during builds. You all want to specify in that definition, and you want to make sure that the tools are there that you need during that build. For the tools that are there, you want to also make sure that they're actively maintained and patched and up to date with patches, of course. From security perspective, that makes a lot of sense. And then whenever you've built something, a good practice is always to make sure that you can verify afterwards that what you've built is actually correct. So you might want to generate like a hash or a signature of the binary or the artifact that you've built, so that when you distribute it, somebody can actually verify that what you've built or what is distributed actually corresponds to what you have built. So you might want to take that into account during the build process. It's always a good practice. So that would be a level 1 activity. If you then want to go to level 2, then it really becomes about automation. So you want to take the process that you've defined in level 1, and you want to automate it in some, for instance, CI/CD tooling or so, making sure that you have, or it can be an IDE, or it can be whatever you want to do it in, but you want to make sure that the build process that you've defined now becomes automated. Why do you want to do that? Of course, for reasons of efficiency, but also for reasons of avoiding errors. Because if you manually have to always execute a build process, you might forget a step, or you might have some typos in executing a step. When you automate it, we want to really minimize the risk of variations in the build process, and making sure that every build always happens in the same way. If you automate the build process, you also probably you will require access to particular repositories and secret files and other types of stores where you might want to need information. So these secrets should also be handled within the build process to make sure that you get access in the build process to these different stores or vaults or other things. But at the same time, make sure that also these secrets are handled properly. So that could mean, for instance, making use of a vault, or making sure that at least these secrets are not just lying around in that build process. So make sure that you properly protect them. And while we're at it, in that automated build process, you also might think about adding security checks or security actions in there. It could be about obfuscation, it could be about source code scanning, it could be about dependency management, it could be all different types of things that you might want to do in that build pipeline. You can add them as steps into the build pipeline. So every time you run that build pipeline, automatically, these security checks are automatically invoked. And then at the third level, there you really want to optimize your build process to ensure that whenever things are not going as planned from a security perspective, the build process will actually fail. And that's actually quite an important difference between the previous step, because in previous step, it is suggested to do this security activity, security scanners, security tooling. In this process, we really want to make sure that security has enough priority or has enough importance in that build process to make the pipeline stop, such that software cannot be produced unless security is really in line with what you expect. Is there anything else that we want to explain on this level? Yeah, we also mentioned something about reproducible artifacts. There's actually, I'm not sure whether you're familiar with the technology, but it depends on the technology that you're using. But in some technologies, you can actually verify that a particular piece of source code led to the binary that you actually built. And that's what's called a reproducible artifact. So whenever you build the same source code, it will actually build the same binary. That has quite some interesting properties from a security perspective, because you can also then really make the link between the source code and the binary. which is for high sensitive applications quite important to know. And that's also something that you can look into the integrity part of things. So in the previous levels, we were discussing about integrity, making sure that you create a hash or so. If you bring it to maturity level 3, we talk about, or we advise looking into reproducible artifacts, reproducible builds, to make sure that you can really make the link between the binaries and the source code harder than through hashes also. So that are the 3 levels of maturity. As a reminder, every level of maturity has one question that you can ask to verify whether your organization or your development team or business unit meets this activity. And in order to meet this activity, you also have to meet all the quality criteria that are defined for that particular activity. So it's a quality mechanism to make sure that this is what we expect as a minimum quality level if you want to meet that particular activity. So let's stop here for a moment on secure builds. Are there any questions or comments on this security, on this particular stream, the build process stream within secure builds?
I guess one remark I would add here, because it's not explicitly stated in the model, is by the time you get to level 3, where you've got these mandatory security checks in place and you're breaking the build on non-compliance, one of the things to make sure is that you've got good change control over the build pipelines themselves. So when your build pipeline becomes an enforcement mechanism, then it has to be tamper resistant. So just don't forget that aspect.
Yeah, no, that's a very good point, actually, because indeed, if you can change your build pipeline at will, then all the things that we want to achieve with it will disappear very easily. Yeah, very good addition, John. Thanks. Right. Are there any other questions or comments on the build process stream? Is it all clear to everybody? Okay. Then we can move to the other stream, and it is software dependencies. So the same structure, 3 maturity levels. At the first maturity level, we want to understand the bill of materials. So all the dependencies in your software, we want to understand. We want to at least know what the bill of material is. So that's level 1, and maybe do some analysis, some intro level analysis on the security of this bill of materials. And a second level, we want to take that one step further and really more rigorously start analyzing all the dependencies in your software to make sure that the risks that are posed in all those dependencies are covered. And well, maybe this is all about software dependencies, is all about supply chain. And well, the Log4j vulnerability that we've seen a couple of months ago really gives you just one example why this stream of software dependencies is so important. So you really want to make sure that your supply chain of all the things that you include in your software that you're building, whether you're buying software or you're developing software, but all the external dependencies that are included in there, they have to be verified for security, and that's what this stream is about. So at the level 2, if you know the bill of material, you want to analyze more rigorously, more thoroughly all these different dependencies and make sure that they contain no vulnerabilities, they're in line with the risk that you want to set as a bar in your organization. And at the third level, we go one step further, is because up to level 2, we rely on all the information that is known about these dependencies. but there might actually be a lot of dependencies for which there actually is no vulnerability or security information known. So in a third level, you want to start analyzing the dependencies that you use yourself within the organization, using all the tooling that you have for security testing, security analysis. You also want to apply those tooling on the third-party dependencies in your software. So this is again the reasoning on the 3 levels. So let's dive into it a bit more. So at the level 1 activity, so it's creating this bill of material. That means that you want to well, look at dependency managers or look at other ways of making sure that you can understand what are all the different external libraries that you're including in the software that you're building or installing or buying. It's important to realize that very often this is a very recursive thing, and that's also what dependency managers typically do for you. But if you include one library, it will typically include 10 more libraries to support that one library, and those 10 libraries will need another 50 libraries. So it's a very recursive thing. So it's something that you really want to do with tool support. Typically, dependency managers can do that for you. But my experience is that even with these dependency managers and some of more specialized tooling on software bill of material analysis, it makes a lot of sense to verify everything that comes out there. But because I've seen quite some situations in the past that there's actually use of libraries that do not show up after the analysis of these particular tools. So do make sure that when you use such tools, do some sanity checking to make sure that the output of this the tools is actually correct and valid. But you really want to make use of a tool to do that kind of analysis, because doing it manually is kind of a nightmare. So for all the dependencies that you get out of these tools, you want to know specific information, its origin, version, very important. License information, because you want to make sure that you're in line with the license of that particular library. And then also, what's also interesting is support and maintenance, status of dependencies. Very often these dependencies are open source libraries, and you want to get some feeling about how well are these libraries maintained. So this is all user information that you can get out of there. Very often, there exist tools that can help you with that. The OWASP dependency checker, for instance, is one of those tools that can help you with that. But there's quite some commercial tools as well that help you do that. All right, that's at the level 1. At the level 2, we have actually, we go one step further. And so we have that bill of material. And now you want to regularly verify all the dependencies that come out of this analysis to make sure that indeed they are okay from a risk perspective, so they don't contain any vulnerabilities that are that should make you worried. That also to make sure that they're in line from a policy perspective with what you expect. So if you're building an open source solution, you want to have open source licenses in there as well. And you want to also reason about whether this dependency makes sense for the software. So let me give an example. If you have a graphical library to show a table on the screen, you might in your organization have softwares with 10 different graphical libraries to show tables on the screen. So you might also want to rationalize about, okay, what are the dependencies that we want to use? Does it make sense to have 10 different libraries for showing a table on the screen? Can we rationalize, and can we maybe also well, manage these different libraries? The idea is here that you actually do this analysis, and that you also create defects if you encounter issues with it, and that links to the defect management stream in the OWASP SAMM model. And so it will give you an automated way of analyzing all these libraries, and also to treat the non-conformities through a managed solution within your organization. That's a level 2, and then going at a level 3 is, as I said before, taking it one step further. So one of the elements here is that you rather in level 2 you're more looking at outliers, in the sense that things that are not okay from a risk perspective. At the level 3 we take it the other way around, and we maintain more like a whitelist approach, where you say, okay, these are the lists of approved dependencies and versions, and all software being built should obey this list of approved dependencies. So it's a whitelist approach rather than a blacklist approach in a previous maturity level. Then, as I said before, because quite often there is no security information known on these dependencies, you might want to do all the security checking that you do on all the software that you built yourself, also apply them on these dependencies. So that might mean doing SAST scanning, doing other types of analysis, looking for backdoors, looking for other types of problems in there, and apply these to the dependencies as well. Also here, similarly, all the issues that come up, we will track them in the defect management system, and we will integrate this into the build pipeline to stop the build whenever there's problems that are not in line with the policies that you have in your organization. So that's at the 3rd level. And again, similarly, every level has this question and this quality criteria to give you an idea of what we expect for every level to be there, and how you can test every level, whether your organization meets the level, yes or no. So those are the 3 levels for dependency management. Are there any questions or comments on this one? That might mean that it was all clear in terms of explanation. That would be very nice. Or maybe it didn't make sense at all. That's also a possibility. Okay, I hear no questions or comments.
Yeah,
Means,
I'm not one to pass up throwing in my 2 cents. But just one of the things on the software dependencies is you can satisfy what's being asked of you in this stream on a project by project basis. So you might use dependency check from OWASP. Where you see a lot of value in having this information is when you're using a tool that lets you look across all of your projects. So OWASP dependency track, or any of the various commercial SCA tools. When you get, one of the things that we saw in December with the Log4Shell vulnerability was that a lot of people spent a lot of time going through projects one by one, figuring out who was using Log4j. Where if they were using an SCA tool that gave them that cross-portfolio view, they could say who's using which versions and just get a report. So once you get to the point where you're generating the bills of materials, look to get that value add by using an enterprise portfolio tool to be able to do, cross-portfolio analysis. Obviously, we can promote dependency track because it's an OWASP project. There are a lot of commercial tools of varying price levels that also do this well.
Yes, indeed, John. Thanks for those additions. All right. If there's no other questions or comments, I would suggest to stop the recording here. Let me stop the recording.